we have a new probe tip on. It is a 50 millimeter long probe with a 4 millimeter ball at the tip. This is on a manual wrist, which means that you change this manually and the angle manually for wherever you want to probe. Let's take a look at the part that we have here that we're going to work with. So this part right here, we're going to be probing from the top, from this face, and on this side. So we are going to have a variety of wrist angles and directions that we want to operate in. So if we take a look back at this wrist, we're going to want to operate it in this orientation where it's coming straight down. We're also going to want to turn the wrist 90 degrees, or 180 degrees, I'm sorry, and we also want to move the angle to 90 degrees so that we can reach around to the front of the part. Additionally, we're also going to want to use it on the side a little bit, so we will also want to do this in this direction right here. So 90 degrees with the angle at 90 degrees. So for every one of those positions that we have this, we need to put a calibration in place for this probe. So the way this is done is we mount a special calibration sphere down onto the table. This is the calibration sphere. It comes with the instrument, and on it, it has information about how big the sphere is written right on its face. And that's information that needs to go into the software so that it knows just how big the sphere is when it's making measurements around it. This calibration sphere mounts right to the table surface. It screws right in, or it could be located in some other way. As long as it's solidly fixed to the table, then we can start to make measurements on that. So from here we're going to go take a look at the software. We have a number of things we need to set up in it. So when we go into the software and we open up a new file, we're going to write a brand new program. You're going to get this Probe Utilities dialog box straight up. In it, you can define which probe you're going to use. There's a drop down here for the different types of probe that you have in there, and their calibration files are attached. Similarly, you can come up here to insert hardware definition probe. That also finds you the same location. So in case you close this out, you can reopen it again. We started by creating a name for this particular probe. I call it tip 4 by 50 millimeter. It is a 4 millimeter ball, 50 millimeter shaft length. Now, in order to build this file for the first time, there's some definitions that need to go into place. In this particular machine, we have a manual wrist, which means that you manually move the wrist around and change the angle. On an automated wrist, there are a variety of components that come down before you get to the actual tip itself. And every machine is different. You have to understand what you have in place between the arm and all the wrist components down to the tip. So initially I have to click on this thing that says no probe defined, and then in this drop down there's a variety of wrist pieces of information in here. In this particular case, I have a Tessa Star I wrist, and it shows it in the picture there. And then on top of that, there are joints. So again, if I look into this list now, I want to find the joint angles. Let's see, where are we? Oh, I think I have to actually highlight. Oh, see there, I put them in. put the joint angles in automatically as soon as I started hunting. And now I have to actually put our tip onto there. So our tip is 4 by 50 millimeters. It says it right there in the list. So I just pick that, and now it shows the entire wrist and tip complete on there. So this is just the beginning. We've just told it what hardware we have in place to start making our calibration. Now we have to go into this dialog that says add angles. And this will look different depending on what you have in here for wrist components. This particular wrist has a certain number of divisions in angle and in rotation. Everyone is different. Some of these are much more fine. Your grid may be much larger depending on what you're working with. So in this particular case, we are going to use this B0, A0. That means we're straight up and down. We're going to keep that. Now additionally, we talked about having a 90-degree angle and a 90-degree rotation and 90-degree angle. So we're going to click on that part of the grid, and it shows it now in that orientation. Additionally, we wanted to have it facing straight back, so we would go with 180 and 90, and now it shows it facing back. So those are the three different locations that we want to have the probe at, and from that we will make calibrations. So now that we've done that, we have the basics information in here. It shows up here in this active tip list all of those orientations. Now what we want to do is actually perform the calibration. So we're going to come up here to measure, and we're going to take a look at some of these probe pieces of information. Number of hits is 13. That means it's going to take 13 hits around that ball, and it's only going to come down to about halfway. So if this is the ball, it's going to touch it on top, and it's going to work down to about halfway through, and it's going to work around the probe, and it's going to make a number of different levels. So what we have here are pieces of information around that. So we have in here 4 levels. Our start angle is 0, and our end angle is 90 degrees. So it's going to come down to 90 degrees on the ball. And then additionally in here we're going to do what's called man and DCC. So we are going to take a manual hit on the top of the ball, and then from there it's going to know to make all of these different measurements on it. Down here at the very bottom is a listing of the sphere. I've already used this sphere, so all the information is complete about this, but if I was to put a brand new sphere up, I would add the tool here and put in the specific information on the tag about what the size of that ball is. So we're ready now. We're going to start. We're going to say measure. And now it's going to ask us, has the qualification tool been moved? We're going to say yes, it has. A manual hit will locate the tool. It's a safe bet whenever you put the sphere on the table. Take a manual hit on the top of it before it starts making the calibration. So we're going to say OK. Now what it's telling us here is to make sure that we have the tip rotated to 0 and 0, which means that the probe is straight up and down. So if I say yes, OK, say yeah, rotate it. Now it's asking me to take a hit on the top of the sphere. Okay, so we're going to bring the probe up. And we're going to drop it down. Bring it up here close to the ball. And I want to get this as centered as I can over the ball. I'm going to put this into turtle mode so that it comes down nice and slow. We're going to make a hit on the top. Like that. And then we just say OK with this. And now it's going to start taking hits around the sphere. It takes 3 on the top initially just to sort of locate it. And now it's going to its 90-degree location. And it's making hits all around the sphere. It takes a minute or two for this to complete its routine. And there, it's completed that. Now on the screen, which you can't see at the moment, it's saying to rotate to T1A90B90. So on the wrist, we're going to rotate this to 90 degrees, and we're going to take the angle up to 90 degrees, like so. Okay, so I tell it, okay, we have done that. Now it says, take a hit on the sphere. So it's the same thing as before, only now we're in a slightly different orientation with this. So we're going to drop it down on the top of the ball, like so. And I'm going to say, okay. And now it's going to go ahead and make the measurements with the probe in this orientation. So you can see it's really looking at a whole different set of surfaces on this. So while it's doing this, we could talk a little bit about the probe itself. The probe can really only contact something very slowly, touch it very lightly. If it runs into it too quickly, it will crash and then the machine will stop. Okay, we're at a point now where it's saying to rotate to ID T1A90B180. So A is the angle here, but when we're talking about 180, we're talking about that. So we have done that. We're going to say, okay, we've rotated it. Now it's saying again to take a hit. So same thing. Only now we're coming at it from a slightly different angle. We just want to make sure that we touch it on the top of the sphere as close as we can. And then say, okay. And it's going to now calibrate with the probe in this orientation. So back to the discussion on touch probes. Touch probes can be hit straight on, they can be hit on the side, and they will create the necessary response back to the machine. The only thing that you have to really keep strongly in mind is that when you come in on a part, if the part is at an angle and you touch it, it's only going to sense the direction of the ball in the direction that you approach the part. And as such, you may actually be not probing the surface you thought you were if the part is at an angle to the ball that you're coming in with. So just something to keep in mind when we go into programming a little bit more. Calibration routine is just about done here. And then we will go back over to the software and take a look at what it has to say. Okay, so we have completed the initial calibration here, and let's see what it says. So it tells us Measured probe diameter error exceeds the limits for all three of those angles, which is really not the result that you're looking for if you really want everything to check out perfectly and have no errors at all. So the bottom line is here, I have to go back through and repeat this calibration in order to get it to be complete. So I'm going to do that now, and we'll come back and take a look at it as soon as I've completed that. It's asking me right now, do you want to repeat the calibration for the selected tips? Yes, I of course do want to complete this. So here we go. So I have redone the calibration, and this time we came back with no errors. And the way we know there are no errors is there's no asterisk in front of these line items here. If there was an asterisk in front of any one of them, it would mean that particular item failed. And these are the different wrist and probe angles. So we have a complete calibration. The issue that we had was in my specification of this probe tip. I had not used this probe tip before, and I incorrectly had said this was a 4mm ball. It is in fact a 3mm ball. So given that all of the calibrations failed, that's a good indication that you have a setup issue. Something wrong with the way you specified the tip or any of the associated parts. If you had an automated wrist and if you have multiple probes, you would have to make sure that if you're changing probes during your operation that you've calibrated all the tips that you want to use. So in this case, we're good to go now. All I have to do is say OK, and we are set up. If you look now in here, you'll see that it specifies this particular probe. Well, actually in here it says load probe tip 4x50 and load probe tip 3x50. I really need to get rid of that particular line in there so that it's not confused later. So that this should be gone now. Alright, so we're going to move on from here and do some new and interesting things. Let's just talk a little bit about what we have here in this PC-DMIS window. So let's just start by saying that there's a number of different pieces of software that are used with CMM. This particular one is called PC-DMIS. This is issued by Hexagon. It may be used with a variety of different instruments. We have 3 different instruments here. They all use PC-DMIS. PC-DMIS is fairly basic. It's a good all-around program. It maybe doesn't have quite as much depth as some of the other programs like Windows, but this will get almost anything done for you. Let's just talk about a little bit about what we have here. This side is our program window, and we're looking at this in what's called command mode. Command mode is a top-down writing style. Every command that you add is going to have to be at the bottom of this and added on to it sequentially. Additionally, we can look at it another way. We can view this in what's called summary mode. So summary mode is much like the way you would read a directory on a computer. You have little plus signs where you can open things out and look at them with more detail. It is a sort of a neat way of looking at your files. So if you're looking for a particular command that you did several times in a program, you can more easily get to that by pulling out the header for that, opening it up, and looking for your particular item. But typically when we're going to be programming, we're going to be doing it here in command mode. This window right here is your graphic window. This is where we're going to see all the measurements we make on your part. If this was a live window, if we're using a camera or whatever, we could actually see visually what we're looking at here. We can also load a CAD drawing into here, and a CAD drawing is going to have a picture of your part, and it's also going to have all the measurement data associated with the CAD drawing. And we're going to draw upon that when we make measurements. This bottom window here is called a status window. When you're making individual measurements of parts, it will show you each hit that you make on the part. and it will have that open until you accept the part shape. And I'll go into more detail about that. The top here we have our normal sort of file commands: file, edit, view, insert, operation, window, and help. Everything that you see here icon wise can be found in here as well, and many other things. This line right here shows the tip that you have loaded. It also shows the work plane that you're working in. And this is important if you're changing the view and orientation of the probe as you're probing things. These things right here will allow you to change the view of the part. And this title bar right here, or icon bar, is sort of an all-in-one. It encompasses all the same things you're going to find spread out elsewhere here. I'll just give you a very quick tour of some of the items here, but we'll go into more detail with them as we move along. And a lot of these things will become apparent as we start using them, and we'll have different colors associated with them. To run a program or execute a program, we use this triangle right here, much like play on a tape deck or CD player, whatever you have. These are alignment tools. We'll discuss that at length. These are probe tools. And then there are a variety of functions that are going to go from gray to other colors when we start making measurements. And these red items are what you're going to report out. These are your sort of your GD and T symbols. So we're going to start setting up our part here and moving along with the lesson.